In this lesson, we're going to talk about usability principles, specifically the usability principles of accessibility, effectiveness, safety, utility, and learnability. These 5 usability principles are an essential part of this course. They will appear as explicitly mentioned in every ISMG or criteria sheet from all the assignments, and they can also appear in the exams. So it's something that you really want to pay attention to and really want to understand really well and be able to apply and use. So in this video, we're just going to talk about the definitions of them. But in subsequent videos, we'll talk about where we can see them exhibited and potentially also how we can use and apply them. So usability principles are very important to this particular course. So what is usability? Well, usability is a measure of how well a specific user in a specific context can use a product or design to achieve a defined goal effectively, efficiently, and satisfactorily. So what does that mean? It means that when we're dealing with usability principles, we need to consider each of the users in our situation or scenario and what their specific needs are, and whether or not they can use the solution that we are either investigating that already exists or the one we are developing. We need to design and build systems that can cater for them and their different needs. Usability is always tested. It's tested from the very beginnings of the project until the very end of the project when we finally deliver it. So the design's usability depends on how its features accommodate users' needs in different contexts. So what is usable in one context may not be usable in another. In digital solutions, we're going to consider usability based on 5 different characteristics, or as they're known, usability principles. These are accessibility, effectiveness, safety, utility, and learnability. Accessibility. Accessibility is the ability of a product to be used by many different people, even those who have disabilities or different physical abilities. The practice of making sites accessible also benefits other groups of people, such as those using mobile devices or those with slow network connections. Accessibility is, in fact, in some places in the world, a legal requirement of websites or products that are considered or built. If a system is accessible, that means it is perceivable, operable, understandable, and robust. So you can remember that using the acronym POUR, P-O-U-R. You don't want to have poor accessibility. So we're going to go through and we're going to think about these 4 terms and what they mean in terms of accessibility. Okay, if something's perceivable, that means that information and the user interface components are presented in a way that users can perceive. That means that a user can actually find it on the page. It's got to be visual or audible. It's got to be able to provide them feedback in a way that they can understand. It has to be operable. This means users need to be able to operate the interface. So it can't require an action that the user cannot perform. Now, if something's operable, that means that it can be used or accessed using different means. So for example, if you have a website, you can't require the user to use a mouse for everything, because some users may not be able to use a mouse because of some type of physical requirement that they have, and they may need to use a keyboard. So you need to be able to make the website operable using different means or forms of technology. It needs to be understandable. That means the user needs to be able to understand the information that's being presented to them. That means you can't give them language on the page that is too difficult, too dense, or for them to read or understand, and make it too hard for them to perform the particular tasks that they need to do on that particular website. And finally, it must be robust. It means that the content should be accessible regardless of the means through which it is being accessed. So it doesn't matter if the user is using a desktop computer, a mobile phone, or some other form of display. They can still access that information and they can use whatever means of technology is available with those particular devices to interact with it. So what it means to be accessible? It needs to be perceivable, operable, understandable, and robust. Effectiveness. Effectiveness is concerned with the ability of users to use the system to do the work that they need to do, and it includes reliability. So that means, just talk about reliability, if it's reliable, that means it's constant and dependable, or consistent and repeatable. So when you evaluate against effectiveness, you're looking for things that work or do not work as expected. So effectiveness is concerned with how well the user can actually achieve the task that they need to achieve. Safety. Safety is concerned with the user's ability to make errors and recover from those mistakes. It's not concerned, in our context, with cyber safety. That is a different concern. Safety considers the questions: how do users actually make mistakes or use our products incorrectly or inappropriately? How bad are the mistakes that they make? Do they crash the entire application? Does it have no real effect if they hit the wrong button? And finally, how easily can they recover from those errors? If a user hits delete and they didn't mean to, can they undelete and recover their information? Or is hitting the delete button at the wrong time a terminal error, forcing them to completely start over again? So safety is an important aspect to consider because we want to prevent our users making serious errors. For example, losing all of their data or information. So examples of designing safely could include not putting a delete button next to the save button. Because if they're close to each other and they are small, you could accidentally misclick. You could provide users with different ways to recover from errors, either by reverting to a previous state or progressing the system to the correct state or changing the information to match what it should have been. Additionally, you could do things like, if you have a form on a website, you could make the input form, the text input, wide enough to accept all the possible inputs the user is going to type in. So for example, if you are after someone's name, you would have to have a wide text box, because if you limited it to say 12 or 14 characters, you may be preventing some people from fully entering their name if they have a name that is not generally from an English-speaking background. So it's always better to try and design a user interface to prevent a user making an error in the first place. So when you evaluate for safety, you really need to consider all the things that could go wrong. And when you've thought about all the things that could go wrong, you need to find ways to prevent those errors occurring in the first place. So this means that for every particular interface that you develop, you're going to have to do the safety analysis from scratch, because every single interface is going to be different. So essentially you need to write a checklist. And then you need to go through the checklist and find ways of preventing everything in that checklist from happening. Learnability. Learnability is simply concerned with how easy it is for a system to be learnt. Is it intuitive and memorable? So if I use it once, if I come back 3 days later, am I going to remember how to use it? Does it match things that I am familiar with, that I've seen before? There's nothing wrong with following a design pattern that other organizations have done and used successfully. Does it use standardized controls? So if you're playing a game, you can use arrow keys or WASD. They are accepted and generally well-known forms of control. If you move the keys around, you may confuse your users who are expecting some type of other interface. Learnability includes how quickly and easily users can learn to find information, complete tasks, and navigate through a digital solution. According to Nielsen, there are actually 3 aspects to learnability. So this is first use learnability. It's asking the question, when I first encountered this solution and I'd never seen it before, How easy is it for me to use? This is really important because if you have a user who's coming to use your system and they're only going to use it once, it needs to be intuitive so they just know how to use it instead of having to go through some type of complex menu system or process that is unknown to them. The second aspect is the steepness of the learning curve. How difficult is it for people who continually use your solution to get faster at performing tasks? Are there any shortcuts that they can use to become some type of power user of your application? And finally, efficiency of the last plateau. So once a user has really learnt your system, there's nothing else for them to learn, so they reach a level of mastery. We're concerned with how productive can a user actually be with your interface once they've learned it fully. This is really important for people who are going to be using your system continuously and use it for everyday tasks. How quickly can they perform the tasks that they need to do? So using this as a guide, learnability can actually be measured quantitatively. That means with some type of values. So to do this, you would need to create a list or criteria of the tasks that a user needs to be able to do within your digital solution. What things must they be able to achieve? And then you could actually just sit there and you could time how long it takes them to use it as they become more familiar. So you could time how long it takes them to use it the first time, have them come back and do the task another day, time them again, repeat that a third time. And if they are getting faster, that means your system has a degree of learnability to it. But if they're not getting faster, perhaps the user is not learning how to use the interface. Potentially. If you took that data, you could actually generate a learning curve. Something like this. Utility. Utility is concerned with the ability of a system to provide the functionality that the users actually need. It's a measure of how much satisfaction or happiness that a person gains from a particular application. Users are quite often willing to use a system that is difficult if they get a lot of benefit out of it. Utility is actually really closely related to effectiveness. Because utility is about, can the user do the things they need to do with this system? And effectiveness is, how well can the user achieve the goals they need to do with this system? There are two ideas that you can consider when determining the utility of system. It's how easy is it to use and how useful is it? What can it do for the user? And if we think about these two values, you could kind of graph them. You can measure usefulness and ease of use. So if something has low ease of use, it's difficult to use, and low usefulness, no one's going to use it. It's a reject. Whereas if something is maybe potentially not very useful, but has a high usability, it might be a toy, like a game. If something has a high usefulness and a high ease of use, then it's a really useful tool. People can achieve their goals successfully and easily. But you might also have the last idea, which is it has a low ease of use, so it's a specialized tool, but it's highly useful. So you might have this if you're a system administrator and you're using some power user tools to achieve goals. So that diagram is derived from a test known as the technology acceptance model. The technology acceptance model is a model that models how users come to accept and use a technology. Essentially, it's a questionnaire. It's got 6 questions for the usefulness of a system and 6 for the perceived ease of use. And each of those questions is scored on a 7-point scale. And then you add the scores for all the questions together to kind of plot them on that diagram. The usefulness questions are these ones. And the ease of use questions are these. So whilst these results for utility, however, are quantitative, and you can actually get some type of values and kind of plot where you think a system fits, there's actually no specific benchmark results for this particular test. So it's hard to compare systems between each other. There's just not enough data publicly available. Nonetheless, you can still use this test to get an idea of or prediction of the overall utility of a system.